Alright, welcome back to generative deep learning, the creative side of machine learning. Basically what we do is we're gonna take data, can be text, can be a picture, can be music, and we're gonna train the data and learn the statistical structure of that data. And we're gonna do this through deep learning. Remember, we had a text in the previous video. The text was from Friedrich Nietzsche. Yeah. And we ran a GRU model on the text to find the parameters of that text. And then the output of the GRU was a softmax. Yeah, let me put it this way. A sort of distribution that was a softmax. And what we did then is we reweight that softmax and generated new text by sampling from that softmax. Yeah? And we had to define a hyperparameter, and the hyperparameter was called temperature. And to be more precise, it's softmax temperature. The higher we chose the temperature to be, the more randomness you create in your generate text process. Yeah? And we could see at lower temperatures, because it's a balancing act, the lower the temperature, the more predictable, or the more repetitions of the same character and words you get. We could actually develop or create a new text based on the structure of Nietzsche's writing and based on the topics Nietzsche chooses. Now we're going to look at a second application, which is called neural style transfer, and this will be related to images. Alright? So neural style transfer was invented by Léon Gattis in 2015. And what is the concept? Well, the concept is that I have a content image, and this content image could be a picture of yourself. And you have a style image, and a style image could be a picture of a painting of Einstein from Andy Warhol. Yeah? And you want to create a new image that still shows you, yeah, that still represents the content, but that has taken the style from Andy Warhol and generate a sort of combined picture. Yeah? So here you should still recognize you on the picture, but it will be in Andy Warhol style. Alright, so in order to show what happens, we'll take a look at one of the CovNets that are available in Keras. And one of these CovNets is VGG16. Remember, we used that in the past. We also looked at ResNet 50. But here we're going to work with VGG16. And some facts, while it's a convolutional neural network, it has 16 layers, hence the 16. And it comes standard with Keras. Yeah, so that's quite convenient as well. It has 14 million parameters. Filter size is 3. We do max pool size of 2. Activation is ReLU. And it has been trained on ImageNet, yeah, as most of these CovNets have been. So if we need to define a cost function, we will have a cost content that defines how similar the content of C and G are. So this is a function of C and G. And then we have another cost function that we call C style, and that's a function of S and G. Yeah? So this is exactly what I wrote here. So the cost function of neural style transfer is the cost function of the content plus the cost function of the style. And here we also define two hyperparameters, allowing you to change the relative importance of both style and content. Alright? Okay, as we are using VGG16, I think it's useful to refresh our memories on how this CovNet looks like. And I've drawn here the convolutional layers, and I'll explain both of them at the same time. So, VGG16 takes images of size 224 by 224 by 3. The 3 comes from the fact it's a color picture, RGB. Then we have a set of filters of size 3, and in the first CovNet block we have 64 of these filters. The times 2 means that I have 2 CovNet layers, and you can see that here there's 2 CovNet layers in the first block. Yeah? Okay, so the outcome here has a size 224 by 224 times 64. 64 because we have 64 filters. Then we're going to apply a max pool, so the size of the activation maps is divided by 2. So it gives us 112 by 112 by 64. Then I have a second block of 2 layers, which is this block. But here I double the number of filters. Yeah, double the number of filters to 128. And I max pool again, so the size is being divided by 2. So I have 56 by 56 by 128. Then I have a block of 3 layers, which is this one, 1, 2, 3. Alright? The number of filters doubles again to 256. And after max pooling, the image is 28 by 28 by 256. Then I have block number 4, which is this block, and block number 5, that is this block. And at the end of block number 5, after max pooling, we have an image of 7 by 7 by 512. So here you have 512 filters in the final 2 blocks. We then have 2 fully connected layers and a softmax 1000, meaning 1000 potential classes. Now, it's important to remember that the deeper we go, the more abstract. Yeah. So if you take a picture of a bike, the deeper you go, the more you will see the bike reflected in your activation maps, because it cannot keep all the details, mainly because the size is so small, 7 by 7. On the contrary, if you want to have detailed features, like in the beginning, you will detect for edges, texture, color, and so on. Yeah, this is happening in the more shallow layers. All right. Now, if we want to preserve the content, yeah, we can easily and intuitively find out that the signal to tap into in terms of generating content is going to be a signal in the deeper layers. And we only need to tap from one layer. So in our case, this is the green line here, all the way to block 4, layer 3. That's where we have the reload. So that's the signal we're going to tap for content. Yeah. When we look at style, it's different. Yeah, because style looks at local features. So, but also looks at global features. So style, and remember when we looked at CovNets, In the beginning, you learn to detect, edges, then a little bit more roundings, then a little bit more looking like an eye or something, right? So they're important everywhere. So if we want to, have the style to be taken here, we will need to tap from all these COFNET blocks. And I always took the last layer of each block. So the generated image, which is the red line, has to tap from the style outputs and also has to tap from the content output. And this will allow us to create a picture with same context, different style.